This is tonight's video about perfect squares and square roots.
Welcome to an introduction to perfect squares and square roots. In order to better understand square roots, we need to spend a little bit of time talking about special numbers called perfect squares. Perfect squares are the numbers that we obtain when we square an integer. So here we see the integers from 1 through 10, and if we square them, we get perfect squares. So if we wanted to, we could expand them. 1 squared equals 1 times 1 or 1. 2 squared is equal to 2 times 2 or 4. 3 squared with 3 times 3 or 9.
What I would like you to do now is try and work the rest of the problems. 4 times 4 is what? 5 times 5 is what? And so forth. So pause the video now and try and work the rest of these problems in your notes. And then unpause the video. Make sure too that you write down that these numbers are perfect squares.
16, 25. Over on the right we have 36, 49, 64, 81, and 100. So all of these are considered perfect squares. Again, if we take an integer and square it, we obtain a perfect square. Another way to think of a perfect square that will help when simplifying square roots is to think of a perfect square as a number that has two equal integer factors. So now that you have a feel for perfect squares, let's go ahead and talk about square roots. To determine the square root of a number, we have a special symbol as we see here. This is the square root of 9. The square root of a number is the number times itself that equals the given number. What that means is, to determine the square root of 9, we need to determine what number times itself would give us 9. And since 9 is a perfect square, we can write 9 as 3 times 3, or if we wanted to, we could write 3 squared. Therefore, the square root of 9 is equal to 3. And again, the is 3. 3 times 3 is equal to the given number 9.
I would like you to copy down the definition of a square root. The square root of a number is the number times itself that equals the given number. Make sure too that you work the rest of these examples while a video is paused, and then unpause it to check your answers. Again, pause the video, write down the definition of a square root, and try these other three examples: square root of 36, square root of 49, and square root of 81, before unpausing the video to check your answers.
Therefore, the square root of 36, again, 36 is the perfect square, because we can write that as 6 times 6, or even 6 squared if we want. And this will equal 1 factor of 6. Again, the reason this is 6 is because 6 times 6 is equal to the given number 36. Square root of 49, because it's 7 times 7, or 7 squared, equal to 7. And let's look at one more. The square root of 81, because 81 is 9 times 9, or 9 squared, would equal 1 factor of 9. One more thing I'd like you to notice is that taking the square root of a number and squaring a number are opposite operations, or could be called inverse operations. Notice here we have the square root of 3 squared. The square root and the square undo each other, and the result is just 3. Here we have the square root of 6 squared. The square root and the square undo each other, and the result is 1 factor of 6. Now, there's one more thing we need to discuss. Actually, numbers have two square roots. If I asked you, what are the square roots of 25, notice we can obtain 25 from the product of positive 5 times positive 5, and also from the product of negative 5 and negative 5. So if somebody asked, what are the square roots of 25, we would actually say positive 5 and negative 5. However,
Really fast. If I'm asking for the square root, 9 times out of 10, I'm asking for the positive square root. If I want the negative square root, I will specifically ask for the negative square root. Most of the times when we talk about square roots, we talk about the positive square roots, not the negative square roots.
To avoid confusion, when we want the positive square root of a number, we use this notation here called the principal square root. And if we want the negative square root of a number, we just put a negative in front of the square root. And this avoids confusion between which square root we're referring to.
And you'll see this in my class. When I want the positive square root, you'll see the regular square root number. And when I want the negative square root, you'll see the negative sign in front of the square root sign.
Now let's go ahead and take a look at two more square roots. If we take a look at the square root of 20, there isn't a whole number times itself that would give us 20. So square roots only simplify nicely when this number under here called the radicand is a perfect square. The closest perfect square that is less than 20 would be 16. And the closest perfect square that is greater than 20 would be 25. And since the square root of 16 is equal to 4, and the square root of 25 is equal to 5, the square root of 20 must fall somewhere between 4 and 5. And in order to get a closer approximation of the square root of 20, we usually just use a calculator. So let's go ahead and do that. On this calculator, press second x squared. It brings up the square root symbol, and we just type in 20, a close parenthesis, and then press enter. So if we wanted to round this to the nearest hundredth, we could say the square root of 20 is approximately 4.47. Remember, what that means is that we take 4.47 and we square it, we should get approximately 20. Notice it's slightly less than 20 because we did round this value. So unless we're taking the square root of a perfect square, we normally have to get a decimal approximation.
Alright, we're going to stop right there because tomorrow night's video will be more about approximating square roots of non-perfect squares. Hope you enjoyed the video, and I look forward to seeing you in class tomorrow.